Welcome to my PowerPoint on my new book, The Advancement of Knowing Toward a New Scientific Method. There are many reasons that we think that we might need to change our approach to science. Francis Bacon gave us the greatest advance in our scientific method in the history of humankind. In his book, The Advancement of Learning, he gave us the complete approach toward theory and experiment, induction, deduction, going back and forth, changing and remodeling our theories in accord with experiments and observations. But he went even further than that. Here's a quote: "The truth of being and the truth of knowing are one, differing no more than the direct beam and the beam reflected." So we are going to reflect on that. He even talked about advancing knowledge, the advancement of knowing, in his book, The Advancement of Learning. But he didn't get deeply into it. So the scientific method we have used for so long was well formulated in about 1620. It was published about 400 years ago by Francis Bacon in his book, The Advancement and Proficience of Learning. And notice on the left, it says, or the partitions of science. So he was able also to divide up science into different types. My book includes two parts, two books in one. Number one, suggestions for a new scientific method, which I will explain in this PowerPoint. And number two, its applications to brain states and how to tap them and master the possibilities for our lives while awake. I call it the possibility codes section. And there are other PowerPoints that come after this, talking about that. So first, let's talk about the brain states. For the longest while, we thought that the highest frequency wave brain state was the beta state. It's when we're awake and most active that we get these brain waves, the beta waves. Alpha waves are when we are making the transition toward starting to go to sleep, and we may be daydreaming. We also could be connecting with the entire universe, feeling a oneness, relaxing. And then when we go to sleep, we first go into the theta state, which usually isn't the dream state at that point. But it becomes that when we go into the delta or deep sleep, the lowest frequency, this deep sleep then takes us back into the theta state of dreaming, and our eyes start to flutter in many cases. And then we come back from alpha to beta. So the sleep process takes us through a process of expanding the possibilities for our lives and then narrowing them down again. So that's maybe one reason why sleep is so important, not just the recharging of our cells and our brain. Here's the current scientific method with a flow chart kind of based on Francis Bacon's ideas. So you'd notice that we have observations, theories, predictions, and evidence. But the flow can be in either direction from or toward either of them. And so we can make a prediction, and if the evidence is negative, we have to go back and revise the theory, like the flow of the arrow going to the left on the above. So there are all kinds of connections between these four means of science. But if we break it down much more simply, as Bacon did in some of his chapters, we see that the scientific method is a process of induction, gathering information and theories, okay, or deduction, formulating theories from that process. So there's an inductive flow from specific instances or observations, and there's a deductive flow from the general principles that we make up to try to describe our observations. So what if we, in trying to understand if our scientific method is right, uh, apply the scientific method to test it? Does that sound paradoxical? That's exactly what we're going to do. And certainly we're going to find that quantum theory upsets the current scientific method, which is so widely accepted. It's the foundation of physics and never been disproven. And it is based a lot on probabilities and transcendence of time. So it suggests several defects in the scientific method, which we'll explore, and then will be several other ones, which we'll explore as well. So the first defect in the current scientific method, suggested by quantum theory, is that there's no well-defined world out there. Before we observe a particle, it has many possible states, not just one. And what we observe is like a roll of the dice. Einstein even objected to quantum theory, suggesting that probability played a role in our observations. And one of the things is that a quantum particle, like an electron, has an uncertainty in location, with different probabilities in different locations, maximizing at a certain point. And so also, quantum theory would suggest our human body has an uncertainty in its location. We could walk up to a wall and all of a sudden be on the other side. It is a very, very, very small possibility that we would observe that, but it is a possibility. So the world out there is manifested in many possible ways by probability. The second defect, also related to quantum theory, is that our usual understanding of the flow of time is defective. In the currently accepted scientific method, scientists formulate hypotheses or educated guesses for why what we observe is the way it is. It's causal and thus time dependent. We're talking about locating the cause of the effect. However, quantum theory suggests quantum reflection into the past. So let's look at Schrödinger's cat experiment. Hermann Schrödinger came up with this mind experiment. You never want to do this with a cat. You don't want to kill a cat. Okay, where you have in your mind a Geiger counter which has a probability of emitting a particle 50% in a half hour's time. If it emits that particle, a Geiger counter detects it, slams a hammer onto a vial of poison. It creates gas that kills the cat immediately. Okay? So when you open the closed box, you don't see this happening. It's a closed box. When you open the closed box, you see the cat alive or dead. And if the cat is dead, you could actually determine, if you could determine the decay, right? When the cat had died, and it has died in the past. So our decisions to observe create events in the past that are quantum probabilistic. Oh, the poor cat had something that went ballistic on him. Okay. Another point of view, David Bohm came up with this idea, and it has been extended by several physicists, that there are quantum parallel worlds. For each possibility of an observation, there would be a quantum parallel world. And so when we observe the cat in Schrödinger's cat experiment, it creates two worlds, one in which the cat is dead when we open the box, and one in which it's alive. These possibilities of quantum parallel worlds also indicate the possibility that different laws might might act in the different quantum parallel worlds. And so there may be different points of view of science in a different quantum parallel world. Different experiences that are unique. The universe we live in is thus unstable and may change its rules with time. And the universe we experience is called by many psychologists now consensus reality, or CR. Arthur Mendel was one of those. He suggested that our consensus reality is a good thing, that the larger goal of deep democracy is not me changing you and you changing me, but we learning how to relate. So how we relate actually makes the world in some ways the way it is, and that's consensus reality. Science has a big influence on the way we experience reality, because most of us believe. Now, an example is how we think about things may influence the way we experience experiments and observations in science. John Dalton, early in the 1800s, suggested that atoms were indestructible during chemical reactions. Now, this was disbelieved by most chemists at the time. And so what happened was that they did experiments to test it, and they all came out negative. But gradually, over 30 years, scientists and people came on board with the idea because it started to make sense with other science that was going on. And the experiments started to weigh in that you could track an individual atom, like a hydrogen atom or a carbon atom, through a chemical experiment. So this shows how our consensus reality can change with time. In fact, our theories have changed with time in physics. All physics theories that I know of, except for quantum theory, have been disproven in some way or in some region of the world in time. First of all, Dalton's theory was even superseded by Einstein's theory. The idea that atoms and particles in them are indestructible, Einstein suggested no, that they can be converted into pure energy of light and movement. This energy then depends on the mass that is destroyed. E equals m times the speed of light c squared, very large energy produced by a small particle. And so we have proven that with particles and antiparticles colliding and converting their masses into pure energy of that amount. However, there may be a transcendence involved beyond special theory of relativity, even in this case of E equals mc squared, by dark matter, which has the effect of a mass but does not have the energy produced, perhaps. So everything except quantum theory has some area in which it's under very strong question or been disproved. Our fourth defect in the current scientific method is that we can't test all possible predictions. Karl Popper suggested that we can't absolutely prove a theory because we can't test every possible prediction because we can't make all the predictions. He said, though, that one of the important things is we test as many predictions as possible, and we also must have a way of finding the falsifiability of that hypothesis. So theories must be falsifiable. For example, what if we theorize that the universe is infinite? After all, the Big Bang suggests that. Karl Popper would say that's not falsifiable and therefore not a legitimate theory, because we could never observe the infinite universe. Our ability to observe would have to keep increasing infinitely. The fifth defect in our current scientific method is that scientists rely on confirmation of observations and experiments. One group or one person is not enough to verify an observation and to apply it to a theory. But one example of this is really magnificent. Blas Cabrera at Stanford actually detected a magnetic monopole. That's a north pole without a south. That's really incredible because normally, we can break up a bar magnet, which has a north and south pole, into two pieces, and each of them will have a north and south pole. But scientists were thinking that the Big Bang must have created this type of magnetic monopole. And he detected it, but no one else has been able to detect it. Therefore, it's not accepted that magnetic monopoles exist in our current universe. Absence of evidence is not absence of the effect, however. So the way he did the experiment was very scientific, and that is convincing to me that we should follow the path of looking for them in other ways. We have, but never found any. The sixth defect of the scientific method is that we get stuck to a theory or group of them by being attached to them. We think they make sense because of all the experiments and observations that have been done. So Thomas Kuhn suggested that the shift of a theory is often a very slow process and difficult. It's a paradigm shift. Scientists and the public get attached to the old theory or group of theories, and they just don't want to let go. There's still so many people who think that Newton's laws are correct, but they get violated when we get near a black hole, for example. And it took a long time for people to realize that the general theory of relativity made sense, and the experiments were done to test it. And the idea of indestructible atoms that John Dalton suggested was a tremendous paradigm shift. It took 30 years for this shift to occur, so there's great resistance to change. This getting stuck is something we should totally recognize. It was recognized by Thomas Kuhn. Einstein even resisted quantum theory for decades. Even after a lot of evidence was coming out, he said God doesn't play dice with the universe. He believed in cause and effect, and that quantum theory did not obey the law of time or cause and effect. So what are our steps toward a new scientific method which transcends these defects? I suggest the first step is to categorize the realm that we wish to explore or understand. After all, consensus reality, or the world out there when we're awake, is only one possibility for science to be applied. The second is group reality. Remember, I said that different groups may actually even experience the world in different ways. They certainly go for different belief systems which influence the way they look at science and therefore influence the reality they experience. An individual reality should be verified as important. The uniqueness of each person. The brain waves of individuals can determine possibilities which are unique for each person, we'll find. We'll get into these in more detail. And finally, brain state reality. The different states of our mind and consciousness work and relate to one another and explain how possibilities appear in our lives. So let's look into each of these ways in which we can explore different realms. The realm of consensus reality we've talked about as the realm of science, but it even goes beyond science. There are beliefs that go beyond science that are very collective and influence the way people experience their lives, what they look for. We are kind of trapped in a cultural context, a cosmic egg. We have to crack the shell and break out of it, right? This is the idea of Joseph Chilton Pearce, who in 1974 published a book called Exploring the Crack in the Cosmic Egg. Perhaps he was the first one to mention consensus reality. In this book, The Crack in the Cosmic Egg, he explains, we are limited by our agreements on possibility. Agreement is a common exclusion of alternate possibilities. And one of our greatest sets of agreement is science, and therefore I would say that science limits our experience of alternate possibilities. And we have to transcend our ordinary way of looking at science to get beyond that. I call science the most powerful religion in the world. More people believe in science than believe in any religion. And it has engaged us in what I call a trance of consensual science, TCS. Okay? The second realm that we might want to explore with our new scientific method would be group reality. How do different groups of people with different beliefs see consensus reality in a different way? And the great example, I think, of that is those who believe that we are causing global warming and those who believe that we are not. And they come up with scientific proof in both directions. Which one are we to believe? Well, it depends on what group you're in. If you're in a religious belief system of a certain type, you're in a group that is looking for disproof in science of global warming. And the other way around, if you're not, maybe you believe in global warming being caused by human beings and oil and stuff. So I would call consensus reality, TCS, the trance of conventional science. I am going to hypnotize you to believe in science. Oh, you do already? I don't have to hypnotize you. Richard Dawkins came up with a great idea of how our thinking influences our reality. It's the science of memes, science of memetics. Basically, catchphrases can change the way we view reality and move in our lives. Here we have a guy saying, I leave homework to the last day because I'll be older and wiser. If anybody repeats that and they go into that trance, they will not work until the last day their homework is due, right? And there's so many catchphrases. I'm so tired. This world is terrible, right? That people transfer to one another, and that influences the way they see the world and see themselves. We have to get out of this trance caused by catchphrases, memes. Timothy Leary also suggests the unique individuality. Although we have consensus reality, he says we view it through our own individual reality tunnel. We have unique beliefs. Each of us has unique beliefs and experiences in life that can tunnel us to seeing the world out there and ourselves in different ways, in unique ways, a unique reality tunnel. Here's an example of that. These are the reality tunnels related to material physics, psychology, and astronomy in understanding the flow of time. For material, there's an arrow of time for material physics we call the thermodynamic arrow. It says that disorder in the universe increases with time. A castle made out of sand will degenerate over a long period of time into a pile of sand. And it's kind of random how that pile of sand turns out, okay, depending on what else is going on and choices of people. And this is called entropy. Disorder is entropy, and it creates what we call the thermodynamic arrow of material physics. There's a psychological arrow in psychology of time. We experience something, so we say this has happened, so it's the past. If it hasn't happened yet, it's in the future. Okay, that creates an arrow of time. As we experience more and more, we move more and more toward the future. Then there's the arrow of time of astronomy we call the cosmological arrow. The universe is expanding over time, and this suggests that time flows from past to future with the expansion of the universe. An interesting quote about time and cause and effect from John Stuart Mill. The belief we entertain in the universality through nature of the law of cause and effect is itself a case of an instance of induction and should be subject to question. Here he is questioning the scientific method as a search for causes of the effects. Wow. This is exactly what I do in my book, The Advancement of Knowing. So although we generally believe in cause and effect, as we said, quantum theory denies it. You can open Schrödinger's cat box after the half hour and all of a sudden find the cat is dead in a certain time in the past. Before we open the cat box, it's both alive and dead. We describe that mathematically in quantum theory. This process of making the cat dead in the past is called quantum reflection. We've done it with particles. Cause and effect is denied. However, John Stuart Mill suggested something about miracles, that they would be under the law of cause and effect. He said a miracle is no contradiction to the law of cause and effect. It's a new effect supposed to be produced by the introduction of a new cause. But that's not necessarily so, okay? And I think he also suggested that. So scientists tend to look for causes of miracles where there may not be. They may be somehow quantum miracles or other types related to consciousness and other modes of being and consciousness. I love the fact that John Stuart Mill in the 1800s suggested the goal of science should be to make us happy. Has it? I call that into question. Also, it's amazing. When you look at yourself in a mirror, the light coming from your face takes a very tiny length of time, a small fraction of a second, to get to the mirror and bounce back to you. So you're seeing your face as it was a small fraction of time ago. But there's another event that really whacks out time. Scientists have measured that when an explosive event occurs, or something that really is sudden and full blast, we see that event a half second earlier than the event occurs. Our brain waves are creating an explosion of brain waves in the brain. It's been measurable. Half second before a powerful event occurs. So if you see a zit on your face, right, you might be seeing it about a half second ago, but delayed by the time that light takes. So it's still roughly a half second ago.